Hello, ladies and gentlemen, and welcome to the new webinar of NKE instrumentation. Today, I want to present to you some tools for determination of cathodic protection need and corrosion monitoring in seawater. So these tools are developed by NKE, and there is on the left part the SCPC, on the right part of the screen the SPCT. So the SCPC is used for in situ assessment of marine structure, cathodic protection need in deep sea or airborne. Just to explain how it operates, I just want to make a short introduction to the different methods which are used for preventing corrosion on submerged and underground metallic structure. The first one is to supplying a current, so the potential of the metal is reduced, the corrosion attack will cease, and cathodic protection is achieved. And the second method used is based on galvanic anode, by connecting the metal to be protected by another and more heavy corroded metal to act as the anode. In this second method, this second method is the principle of the SCPC, which I want to talk to you today. And the idea of the SCPC is to use the housing of the SCPC like the cathode. As you know, the dimension of the cathodic protection is defined following some standard, but the environmental parameters also influence dimension of cathodic protection. And the main parameters which influence this dimension of cathodic protection are temperature, flow velocity, salinity, and dissolved oxygen. So the interest of the use of the SCPC is to make in situ measurement to evaluate the need of cathodic protection in the environmental condition. So this is the SCPC product. This product was developed very long time ago, more than 20 years, with the participation of IFREMER and also with the collaboration of Institut de la Corrosion. Institut de la Corrosion is a French institute based in Brest, and it's a subsidiary of the Swedish Corrosion Institute. So as I explained to you, the SCPC product that I can present to you here. This is the size, real size. The principle is that we use the housing of the SCPC like a cathode, and we protect this cathode using an anode, which is here. And we make two different types of measurement. The first one is the current, which protects the cathode. The current is controlled by internal resistor. This resistor is placed between the anode and the cathode. And the second measurement made by the SCPC is corrosion potential compared to the reference, and this reference is a zinc electrode placed here. So this is the main electrical characteristic. These are the main characteristics of the SCPC. So this is a range of voltage measurement. For the current, we have a very low range and we offer a very low resolution for the measurement. The impedance of the electrical board is very high, so we have no influence of the measurement and on the electrical compartment. This is an autonomous data logger, so we can program recording from less than 1 second to several hours. And the design of the SCPC allows a use up to 3,000 meter depth. The autonomous data logger is based on a specific communication link So we use data pencil, inductive link, in fact, which is placed close to the SCPC to program and collect the data without connector. The internal shunt resistor is selectable from 22 to 110 ohms. The setup of the SCPC can be also made using different galvanic anode. So we use aluminum indium, but we can use also aluminum gallium. The cathode is made with the same metal that you want to analyze. So mainly is steel, C22, but we also make a lot of study with stainless steel. So the advantage of the SCPC is that at the same point we can use several SCPC and with different configuration. The first parameter to adjust is the internal resistor, which limits the current protection between the anode and the cathode. And the second point is the configuration of the anode. So here we show to you the result provided by Untitled Chapter. And they make a study during 11 months, and we see on this curve that the potential of the cathode goes down due to the protection of the resistor. So it means that using several CPC in one depth with different resistor and different galvanic anode allow to you to determine pseudo-polarization curve, as we explained to you in some example on the next slide. Here, in this case, it is 22 ohm and aluminum gallium for this SCPC. So thanks to collaboration of Institut de la Corrosion, I can show to you some results which were presented last year in a big conference in US. They deploy on the mooring line several samples of SCPC. The first batch of sample was placed at 1,000 meter depth and the second batch at 2,000 meter depth. The environmental parameters are also recorded during all the campaign. So these environmental parameters are mainly the depth, temperature, flow velocity, salinity, and dissolved oxygen. Here you can see the main value, the middle value during the campaign. On the first sample holder, we use 3 different SCPC. The first one is use an internal resistor of 33 ohm with aluminum gallium anode and a stainless steel cathode. This stainless steel cathode is the same for the 2 other SCPC, but the anode changed to aluminum indium, and the resistor, internal resistor, is also changed. So the result of this campaign show that different pseudo polarization curve were obtained at 1,000 meter depth and 2,000 meter depth with the different SCPC. Here we can see the variation on the first SCPC from the first day to just close to 1 year after. So the first SCPC was as 33 ohm for the internal resistor and aluminum gallium anode. The second one used aluminum indium anode and 66 internal resistor, and the third one used aluminum indium anode and 33 ohm resistor. So you see the variation of the potential during the time at 1,000 meter depth and 2,000 meter depth with another batch of SCPC. And the main information is that the initial current density recommended by the standard appears under the estimate in contrast to the data collected. So in fact, the standard value of the current is close to this value, and but we can see that at the beginning the current density is higher, in fact. So this is for the main information I can give to you to the SCPC. Another application of the SCPC is very specific, but it can be used also for the biofilm sensor, biofilm evaluation in deep sea. So I can recommend to you to read these papers made by Institut de la Corrosion and contact maybe airborne dealer for any information. So the second product that I want to introduce to you today is SPCT. SPCT is also an autonomous data logger, which record, but this more simple autonomous data logger record mainly the potential corrosion and also temperature. So the SPCT is designed for monitoring, in fact, the effect of cathodic protection on submerged stationary structure like buoy or wharf, and mobile structure like cable, or inaccessible structure maybe in a wind turbine or offshore structure for oil application. SPCT, in fact, is used to make expertise to analyze the origin of the corrosion. It could be galvanic coupling, liquid current, or provided by straight current. So this is the SPCT. It is also, you recognize the internal logger, and the main data which is recorded is the potential of the structure connected to the this bracket using a titanium screw, and we record the potential of this structure compared to the reference electrode placed here. We also record the temperature because it could be an indicator of the seawater temperature. The SPCT exists in two different versions. One is for the shallow water up to 450 meter depth, and the second one is for 3000 meter depth. The SPCT use the same data pencil that I showed to you before. So this interface is placed as shown on the pictures in contact to the SPCT to program and collect the data. You recognize here the titanium screw to connect to the sample to analyze this, and the reference electrode, the zinc reference electrode. So these are the main characteristics of the logger. So we can also program the recording, the sampling. The autonomy is more than several years, so long-term deployment can be made. The voltage of the record, so which allow to monitor different type of sample, metallic sample, and the temperature range. I just want to you for applications the result provided by also Institut de la Corrosion, and which were present also last year in US. In this study, they analyze corrosion on different type of stainless steel. These different types are listed here. All these samples were placed in two different depths, 1000 and 2000. And the monitoring was made during 11 months in Atlantic Ocean. Two depths are, the samples are placed in two different depths, and these are information about the environmental parameter, temperature, flow velocity, salinity, and dissolved oxygen also. So one of the main conclusions of these studies is that the result obtained on the sample are depend of the environmental parameters. So here we see the potential of the sample at the beginning of the monitoring. And after 3 months, the potential of the sample is rising up. So in this case, due to the action of biofilm, the sample is protected. And we can see that depending on the depth, this protection appears after 3 months or after 6 months. Here you see the different stainless steel coupon which were used. So thank you for your attention. If you want more information about the logger SCPC and SPCT I introduced to you today, you can contact me directly. And if you want more information about the different presentation, different papers which were used for this presentation, you can contact Erwan Diller, and thanks to him, to his help for preparing this webinar. Thank you, and if you have any questions, we can have a short talk.